So one last thing that I talk quickly a little. Diffusion controlled growth of plates or needles. Those types of plates or needles, there's very thin plate or long needle, quite often controlled by the led by the so-called incoherent edge or tip. Those edge or tip, this roundish interface, they grow pretty fast. Okay, the growth rate would be proportional to what? Proportional to the delta x 0, which is the supersaturation. The initial concentration versus the equilibrium. That's your supersaturation. And also proportional to the inverse of local radius of curvature. If local tip is sharper, it grows faster. If I have a needle, the sharper the tip, it grows faster. As long as it's larger than your critical nucleus size. Okay? And then the diffusion growth of the plate-like precipitate over the coherent or semi-coherent interface. The growth rate would be proportional to similarly supersaturation, and then the spacing between the ledges, because you can only add atoms onto the so-called ledge side, the special location where you have fewer so-called broken bonds. That's where you are going to add atoms. So the spacing between the ledges tells you, okay, how frequent you are going to add atoms into those locations. Okay, if the spacing is too large, the growth rate would be pretty slow. The spacing. Okay, and the growth process is more complicated.